hit the first of two lectures, which come too late. Every year I try to adjust what I talk about, among other things, to address emerging needs in these projects. And honestly, I left this stuff to a bit too late because I was concentrated on some other aspects that concerned me. Test design. But there's a number of things I really want to impart to you. Hoping that that at least some of these things will be implementable by you still. At the least, they should clarify terminology that you're going to need in professional world. Because this class is not merely about the projects, although those are important, but it's about developing skills and understanding that speak to real-world opportunities for you folks as software engineers. And I wanted to introduce some understanding, clarify some points, and orient you. So, the next two lectures, this and Thursday, are going to be about testing. Okay? And there's way too much stuff I wish I could tell you. We talked about having a whole class on testing in a program, carving it off and having a whole test. And I think that could be good. And so, I feel like I'm triaging and doing a disservice because I'm not able to get you a lot of key points. But I can get you some key points, okay? One thing is this kind of V model of testing. And when you're dealing with a software project in the real world, often you hear about this kind of welter, cacophony of different types of tests that are involved, okay? So one would be like an acceptance test, another would be system test, integration test, unit test. And you may wonder, what's the relationship of these to each other? So I've tried to kind of map out a relationship between them on the right, a sort of test, and on the left, sort of different aspects of the system design or needs as articulated at different levels. So requirements, for example, are traditionally validated by acceptance tests. And in some industries, like in the pharmaceutical industry or highly regulated industries, you'll find a whole cottage industry of people whose job in life is to perform acceptance tests. So they come in as third parties into companies, and they will validate software written by someone else against the requirements, against what's needed. Okay? So they'll perform validation tests before software is commissioned. So this is a really serious thing. Sometimes these acceptance tests are more informal. Sometimes they are essential before the project is declared complete. Okay? So sometimes they're very formally defined. High-level architecture and sort of use cases of a system, broad use cases, are often tested system tests. The defining characteristic of a system test is that while it may not be required for acceptance of the system as a whole, it's going to be testing across multiple features of the system. That's if the user, for end-to-end test. So the user opens the software, they go and they open a file, they load in some information, they perform these tasks, they send off, they indicate the files to be reviewed by someone else, and it queues it up in the workflow. That person leaves, another person now has to review it, marks it as done, and now it's done. So this is kind of an end-to-end test of functionality. It transcends any one feature. There may be many features used as part of it, and it goes across many areas of the system. Okay? And so it's not just about one piece of the system, it's about the whole system performing its jobs in a coordinated fashion. And that's the operative word there. It involves coordination across all pieces of the system. Is the system as a whole operating correctly? Right? Does that make sense? Well, why you might need that? And that's quite different from what we have, for example, on unit tests at the low level, which might test a method, right? Or they might test a class. They're very focused in their functionality. They're focused in sort of a stovepipe sort of fashion on a particular piece, whereas system tests are testing across the entire system, as if the user's using it for a task that's a sensible, coherent task, right? And integration tests fall kind of between the two, with testing how do different components work together? So how do two classes cooperate to achieve a task? How do two pieces of the system work together? So integration tests can be defined actually at several different levels, at the class level, the method level. But they have to do with working across interfaces. And often it's because things fall through the cracks at the interfaces, whether it's in the human domain or whether it's in the domain of computer programming and software development. The interfaces are often where things fail. Two pieces are made by different people with different assumptions, perhaps, and therefore each of them is perfectly reasonable in and of itself, but they make different assumptions and they don't work together properly. Each thinks the other one will handle a certain type of bad situation, and it doesn't get handled. Does that make sense? For example, that's one case. Okay, so what I have not shown here is regression testing, and you folks need to know about regression testing. Does anyone know what regression testing is offhand? Okay, so regression is when a change to a software system breaks an operation that previously worked or failed, or it's put in place to fix a bug, but it doesn't actually, in fact, fix that bug. Okay? And it turns out this class of problems is of particularly keen interest. Why? Well, let's think about it. Suppose that you have a software system that's on release 3, right? Maybe it's a system that people download. Maybe it's a web service that people are counting on, like Google Docs or what have you. And suppose there's a bug in the system. Let's imagine a situation where you have a bug in the system that prevents a feature from working. Maybe for a service, it's all for all of 2 days. Maybe for a downloadable system, you discover it in a week or something like that once people report it. Okay, so there's this bug and it prevents a feature from working. Let me ask you this. If you had a choice between the feature that's problematic, the one that doesn't work, being either a new feature that you've just rolled out for the first time, or an existing feature that's been there for a long time, which would you rather have break? Which would you rather have not working? Josh?
The new feature.
Okay, the new feature. Why?
Because like the SCOF.
Yeah.
The thing is that you need to have what is existing already working because people are depending on the feature to work.
Yeah, there may be tons of people depending on these existing features for their daily work, for their workflow. They're counting on, for that presentation they're making tomorrow, this certain thing in Google Docs will be displayed in this certain way in the Google Docs presentation. They're counting on people being able to log into their spreadsheet for tomorrow's, budgeting meeting or what have you. Existing features, they've wrapped their lives around them. They've come to assume them in how they do things in their own business. So if you break an existing feature, you are not only not offering extra value, you're potentially offering negative value to their lives. Suddenly, they're no longer going to be able to do something that they've been able to do. You've deprived them of the opportunity to undertake certain tasks that they've been able to undertake. You've delivered negative value. Whereas if it's a new feature, oh, great, yeah, we'd like to be able to do 3D fonts or whatever, and you try it, and it looks bizarre in Google Docs, it doesn't work. You're going to say, well, okay, that's too bad. I was really interested in that, but comparatively speaking, it's a lot less bad because you haven't woven it into your life. Does that make sense? Right? So I would say, folks, it's a lot worse to break an existing feature than a new feature. Do people appreciate that distinction? Okay. So, the issue here, folks, is that we want to be extra careful about breaking things that the user is counting on. And At the same time, sometimes we can't test all of the things we've tested in the past as working. And so we have to leave out some tests we used to run because it's just too expensive. And so in those cases, we talk about a regression test gap. It's kind of a window of vulnerability because we're not able to run all the tests we really should have. The entire test suite that's ever been run. I should say ever been run. We'd like to be able to sort of test against that, but sometimes we're not able to. Sometimes we're just able to test current, smaller set of tests, and then there's a vulnerability. Okay, so I talked about these sort of notions that we actually, for regression, it could either be we failed to fix something that we intended to fix, or that something else reemerges. So we talk about a regression test as being a test that verifies the fix is now working. So there's a bug found, perhaps manually, and now you put in place a test that automatically tests for that bug, so that when the developer rolls out a fix, you can run that test against the fix and make sure it works. Does that make sense? That makes sense? That's a regression test. It's testing to make sure that this fix that the developer is putting into place, in fact, works without you needing to manually go through that test again. So often it's an automated test. Generally, it's an automated test, these regression tests. But second of all, you want to make sure that new development or bugs don't break features that were working earlier. You want to make sure it doesn't screw up some feature that's working earlier for the sake of this new feature. Often earlier bugs reemerge. Why? Well, things come back to bite you. Things that didn't work before often stop working again because you make the same logical mistakes, or you have merge conflicts and subversion or Git that leads to overwriting of earlier code, or the same miscommunication. Okay. So with regression testing, the goal is, make sure that previously found bugs are no longer present, test similar bugs, and test other features to make sure they're not broken. And ladies and gentlemen, a smoke test in a classic system does often a small bit of this. It's testing that the basic features are still working of the system. But generally you want to test, other features as well. Make sure you haven't hosed over current users of your system with your changes. Does that make sense? People comfortable with that? Okay. So that was a bit about regression testing and why it's so important. You want to make sure that existing features remain stable when you roll out new features. Make sense? Okay. Key priority there. Whatever you do when rolling out new features, try to make sure it doesn't break old features. Okay. Okay. So we're going to be talking about test levels in this sort of V that we talked about earlier. And I'm just going to breeze through this really quickly. We talked about isolated unit tests. We talked about this notion before. So you have a function foo, and it depends on calling a function bar within it. And if we really want to do isolated unit testing, so it calls off the bar, maybe on some object O. And if we really want to do careful unit testing, we can stub out that bar so that foo calls a fake version of bar, or we mock it out. So we create a mock object for O. That's not the real object O. Instead, it's a sort of fake doppelganger of O. It's something that pretends to be an O. Pretends to be of that class. It's not really. And it may just say that the argument passed to bar is legit. Or confirm that it's only called once, or other properties that you want to check. And so here, the call to bar is actually not occurring to the real bar. It's occurring to a fake version of bar, which does very simple checks and returns known values. Why return known values? Why not return some value determined some complex way?
Because then you have no unexpected output.
Yeah, exactly. So if you're testing foo, you want to be able to test it against very defined assumptions, very defined inputs, as it were. And this scarlet bar, you want it to sort of work in a very clear way. Now you might mock up bar in different ways for different tests of foo, but you want to divide your difficulties. You don't want to be testing all of bar. That's the key thing. You don't want to be testing all of bar. You want to be testing foo. And to make sure that foo is working, you want a very well-defined situation where you call off to bar has very well-defined return values. Now, that's not the end of the game. It's not the end of the story. Later, you're going to test foo with bar in this later thing, unit integration testing. You can testing them together. But initially, you might want to just test foo. It'll help you better understand when it's failing, why it's failing, under what conditions it's failing. It'll help you quicker debug it, etc. If you don't have to get all involved in bar as well, which might be quite complicated. So you have this bar just return a known value. Does that make sense? So mocking, whether it's with Mockito or JMock or what have you, is your ticket often to sort of temporarily stubbing this out, temporarily making it so this call to bar actually occurs to a mock version. And the nice feature about some of these frameworks is that you can just say, hey, test it's only called, 2 or fewer times. Test that it's always given values that are greater than 0. Test that, it is never called after Baz. And have it just return this certain value. And you can say that without actually having to go and implement it yourself as a thing. You could just make these declarations, and the mocking framework will take care of it. Can you see why that might be useful in testing? So if you want to test small pieces first. In the PCR, you want to test foo without testing all of bar. And so you can use mocking. Make sense? Okay. Now, in classic software development, when I wore a younger man's shoes, for example, we would stub things out. So we would actually manually create stubs of bar, for example, and test it with the manual stub of bar and then add in the full bar when it was ready or when we were ready testing-wise to escalate to that level. But we'd have a stubbed out version of bar for now. The beautiful thing about mocking is you can do that transparently without having to modify the code. Okay? Good things. So integration testing, I mentioned that it's done at several different levels, typically conducted by developers like unit testing. Generally in a software project, the developer is responsible for unit testing and for integration testing. System testing is often done by testers, as is acceptance testing. Higher levels of integration testing might be. With integration testing, there's many interfaces in your system, and you're going to be trying to figure out which ones to test. I had noted system testing, sort of testing functionality across the entire program. This, often system testing, will involve some, not always, but sometimes it will involve going through the UI. Sometimes it will involve driving the system from a test harness. Are people comfortable with that test harness idea? You have a piece of code and it says, call method X on this certain piece, and it will call successive things. It doesn't always use that same voice, but it will call these successive things in order to get the work done, just as if the real system did. And you make sure that test works. Other system testing works through a user interface, okay, and goes through automated testing, for example, across the user interface. And I think some of you, in fact, I know some of you are using robots. What's the name of that? The one you're using. There's one that presses the buttons for you and so on. Sorry? Yeah, okay. Robotium? Yeah. Robotium. Okay, yeah. So it goes through, and that's one type of system testing, and it's useful. But what's the problem? This is important, so I want you to pay attention to this. What is one of the difficulties, or one of the challenges, or one of the shortcomings, one of the issues that comes up with automated testing of that sort? So I like it. It's great. You're going through the UI to do some testing, because after all, user operates through the UI. Why not do all testing through the UI, all system-wide testing through the UI? So I were to say, do all system-wide testing through the UI. What sort of challenges would you face?
Testing specific components of the back end.
Good.
Aren't necessarily,
Yeah. How do you? Okay, so you might want to test very specific conditions, and trying to go through the UI to make these happen might be kind of challenging. You could probably rig it so it will happen, but it requires a lot more work to sort of get it in the situation where the backend will do a specific thing, right? So it may just be easier to have a test harness that call this, call that, call this other thing, one after the other, and gets it to go through the paces more directly and make sure those things in the backend are called or what have you. So that's good. So one that isn't going through the UI. What's another issue of going through the UI, though, that you have to watch out for? Yes, that young man, good man, good man. So the UI change is often a lot faster than other pieces of a system, particularly in the long term. I mean, while you're building up a system, a lot of things are changing, but in the longer term, UIs evolve quickly. You know, for usability reasons, because new technologies come out, because new form factors, people want to use it on their tablet as well as their phone. A lot of different issues. UIs change with a much greater churn than the business rules, how things, sort of the basic logic by which it works. So system-wide testing, it's good to have it done in an automated fashion, and there's certain things that are great to do in an automated fashion, but you have to be careful about UI testing, because the tests that you have in place, say with Robotium, to go through the UI, those may break because suddenly, you know, you were pressing a button called this, and now you've changed it. So instead of a button, you know, instead you've combined two pages on now a single page. So now the UI has been reorganized. Maybe instead of a button to press this, you have a link that you click on, and now you've got to go change that code to reflect this fact, or you change the name of the button, or you consolidate pages, or you change a radio button to a checkbox or something like that, and suddenly you need to go back and change the code. Whereas if you're just doing system testing by calling, like call this, call that, call this method, it's going to be less subject to the vagaries of the UI changing. Does that make sense? No? So going through the UI is great to do it some, but you shouldn't do it for all of it. I'll tell you another thing that's a big disadvantage to UI. Performance. When you go through the UI, ladies and gentlemen, the tests run slower. It takes longer for the test to run. Now, for many people, that may not be a big obstacle for a small system, but if you're running, folks, I mean, so Dylan, it works with a system that he built up when he was about your folks' age, not long ago. And I think that system has thousands of tests on it now. And if you want to run tests every time you do a build, for example, you run a test suite, you're not going to be doing thousands or tens of thousands of tests through the UI. Robotium may be fast, but it's not that fast. Just it's not that fast. Even if it does that, right? It's just not going to finish tens of thousands of tests in time for the build to be done lickety split. That may be a term unfamiliar tree generation. But it's not going to complete really, fast enough for you to watch the build be done. You want those tests with the build to execute quickly. And even your overnight tests, the tests that you run overnight against the system that's been, updated during the day. If you did all tens of thousands of tests with Robodium, it would require a huge number of test machines, or they might not complete. A large number of test machines, so they might not complete. You might be able to throw cloud resources on it, but it'll be a challenge. So generally, you want some things, ladies and gentlemen, to be tested through the UI, and some things not. Okay? Some system tests directly. Now, you want to be. I tried to communicate this to you earlier. When I was fresh-faced and young like you. I know you probably think maybe the world was still cooling at that point. But, not sure if that's a cough or a laugh. Okay, I'm sorry. Sorry to hear that. But when I was young, I didn't realize how inconvenient the world is sometimes. Ladies and gentlemen, it doesn't cut it often to do testing on our development machines, which have often lots of memory and lots of disk space compared to a user's machines, and to declare things done and successful. Declare victory and you're done with it. That will reveal a lot of bugs, don't get me wrong, and it's great to find those bugs, but that can't be the end point. That's not it. That's not really doing a thorough job. The fact is, users' machines, users' resources are often a lot more constrained than the ones in your desktop or the ones that you're using for development. And what's worse than that is sometimes, particularly for certain types of resources like web applications or embedded systems or certain types of embedded systems or for certain types of mobile devices, they'll often get in situations that are inconvenient in the sense that they're memory starved, there's lots of demand on the system, and it can't execute as quickly as would normally be the case. And the thing I didn't fully grasp, well, there are many things I didn't fully grasp when I was your age, but one of them was the fact that when you have it vulnerable to being really slow and memory constrained, often that happens at the point where we most need it to shine. I gave the example earlier in class, in an earlier session, of people coming to your website, flocking to your website that you've built, you feel so proud about, and now they're coming, 1,000 a minute to your website, to your web app, and they're hitting it. And the threads are being handed out, and they're getting from the thread pool, and they're getting pretty thin. Users are starting to have to wait several seconds before they see the response. And your database is operating really slowly. And this is where logical mistakes, this is where synchronization errors, this is where not paying attention to transactioning really hurts. Because things start to slow down. And you say, oh, come on, there's just no way that, this is going to get only halfway through its operation and someone's going to come in at this inconvenient point when it's halfway done. They're going to see imagine a situation, you're selling books, right? You're selling books. And someone is flocking to your site to buy, this sounds too plausible, to buy your books, right? They're coming to your site to buy, maybe it's games. Probably like that. Games, okay. So your site's selling games. And the people are coming to your site, they're selling boxed games. Okay, they're selling Xboxes, okay, or PlayStation, whatever you pick your. They're selling something physical. And you have only so many in inventory. And they're coming to your site, and they're hitting it, and they're ordering it so that they get it to them. And so someone's there, there's one left. Someone comes, and it starts going through the process. They say, I want this one. And it marks it for them. They go through and they say, pay for it, right? And it charges their credit card. And just as it's preparing to get ready the shipment information on the back, so in other words, just as it's just before it's going to save all the information in the database, someone else comes in. And they start to buy the same thing. And charges their credit card. And they get along, and maybe by the chance of the situation, they actually complete the transaction first. So the first person to charge their credit card now goes to ship it to them, and it's not in inventory. That's a bad thing. The customer can be quite unhappy. They get charged, and they don't get the goods. If you don't think that happens, it happens, unless you're careful with the transaction. Similarly, a system like the ones you folks are working on can get interrupted in the middle of transmission. Halfway through getting a record up onto the server, the connection conks out. It conks out and there's a half record uploaded. And you don't want that half record then being treated as if it's a whole record, in screwing up the counts, screwing up the statistics, potentially causing things to crash because they found these illegal values in some of the fields that weren't filled in on time. So guess what? Things are inconvenient. Things go wrong when we most need them to go right. They go wrong at inconvenient points. They go wrong because things slow to a crawl. And if you haven't been really careful about getting the transactioning right, really careful about getting the synchronization right, things may go bad. And you want to know if you have gotten those things right in testing and not have the user see this, not have the user, a fuming user say their credit card has been charged without getting the delivery. You don't want a situation where people can no longer use their accounting system because it's got a corrupted record because it was synced from the field. So instead, you want to test your system really thoroughly. So you want to do what's called load testing and stress testing. Test your system under brutal memory shortages and brutal demand. Have simulated people hitting your system frequently to see if it overloads. Have hundreds of users, just like Hassan, streaming things back to the server at the same time. Have thousands of patients, thousands of medical students simulated, all updating their medications at the same time or something like that. So these things are all going on at the same time in a contentious fashion, because that's when your system may show its vulnerabilities. That's when your system will show its weaknesses. It's like flying in a plane. You wouldn't trust flying in a Boeing 787 if it hadn't been tested in stormy weather, if it hadn't been tested in thunderstorms. You don't want it to malfunction then. That's when you most need it to be have structural integrity, and so it is with our programs, ladies and gentlemen. You want to do stress testing. Test your system in starvation conditions with low memory. See what it does. And make sure it doesn't get in a situation where it's permanently corrupted, where you can't even run it again because it can't start up anymore, because the file on disk got corrupted or got cut off because the disk was full. And guess what, folks? There's help in this. You don't have to go out and simulate disk errors by actually causing the disk error. You don't have to bang the disk on the table to make it seem as if there's a disk error. You don't have to actually deprive it of all memory. There's programs that will simulate these conditions for you. Make it seem as if you're out of memory. Make it seem as if you're out of disk. Make it seem as if the network is really slow. One of the programs I used to use back in the day was Canned Heat for this, but you'll find others. And try running your systems like this and see what happens. If it simply fails in a graceful fashion, just can't work, that's one thing. But if it gets corrupted, if it damages data in some sort of way, if it gives wrong results without notifying that something's in error, that's a problem. Okay? This is stress testing. Okay, that's all we have time for today. I appreciate your patience. And wish you the best of luck, and I'll see you on Thursday.
Okay, so I guess we need to, so we're all gonna still meet at 5?
4 o'clock. I'll try to make sure Dylan is here.
No, but like, do we need everybody?
Yeah, technically, risk and build out here.